Let's take a look at our study guide. I do want to apologize. We have some spacing issues compared to the original document, but I am going to go ahead and put the link in the description of the video so that if you guys need to go ahead and take a look at the document, or you want to print it out at home, or you want to just pull it up on your Chromebook to be able to check it out outside of Canvas, you can. All right, so this is with our study guide for just work and energy. We're focused on looking at the formula for work, and of course our formula for work is equal to FD cosine theta, where theta is going to be your angle between your force and your distance. So the first 4 questions, pretty generic. I'm just giving you a force, I'm giving you a distance, and then the angle between, which is 15 degrees. So I'm just going to draw all of mine going to the right because it says draw the vectors and solve for work. You don't necessarily know which direction it's going, so if you want to draw it going upward or downward or to the left or right, that's fine. So I'm going to say that it's going 1.8 meters, and my force, it says, is 15 degrees. So I'm going to keep a fairly small 30 newtons. And when I go ahead and do 30 newtons times 1.8 meters times the cosine of 15 degrees, I'm going to get a value of 52.16 Newton meters. Now, for someone outside of class that may be watching this, we are not concerned with significant digits. So we're just going to carry these out to about 2 decimal places. That's going to be pretty standard. Okay, let's look at number 2. Again, we have a 5 meter displacement there, and then we've got at 30 degrees, which is a little bit bigger, right? We've got a 50 Newton force. So again, we're looking at 50 newtons times 5 meters times the cosine of 30 degrees. And again, you are going to be in degrees, not radians. Excuse me. Number 3, we're looking at 75 newtons and 8 meters. So 8 meters and then 75, what do we got there? 90 degrees. So what is the cosine of 90 degrees? Yep, it's 0. So we don't have to do any math here. We know it's going to be a value of 0. That is true anytime you have any force that's perpendicular to your displacement. All right, now let's look at this last one. We have a force of 100 newtons. That's 180 degrees from the displacement of 14 meters. Again, these are not to scale. So my force is going this way, so 100 newtons. So that angle right there is 180 degrees. So it'd be 100 newtons times 14 meters times -1, because the cosine of 180 degrees is equal to -1. All right, so that gives us -1400 Newton meters. Okay, did we get the value for 2? I don't think we did. 216.51 Newton meters. Apologize about that. Okay, so number 5, this is a little bit different because I'm giving you kind of a scene, and you're looking for the work done by the pulling force, work done by gravity, by the normal force, and then by friction. So there is friction. A couple things, mass of being pulled at constant velocity. So that means the sum of my forces in the x direction is equal to 0, and the sum of my forces in the y direction is equal to 0. So if I'm pulling it with a force of 12 newtons up this way, and I have force of friction down this way, right? I only take the x component of that pulling force. So we'll get there in a minute. Okay, so let's look at part A. We want the 12 Newton pulling force. So that is 12 newtons times 5 meters. That's the distance that I go, times the cosine of 25 degrees. So the work on that one is going to end up being 54.38 8 Newton meters. All right, so the work done by gravity, because that was this force right here, okay, this pulling force. B, let's look at the work done by gravity. Gravity is going to be doing a number like this. So mg, we said it was a mass of 10 kilograms, and my displacement is to the right. So the angle between my displacement and mg is going to be 90 degrees. And we know that the cosine of 90 degrees is equal to 0. Therefore, our work is also going to be equal to 0, right? Because it is not going in the same direction as the displacement. If I look at normal force, similar situation. My normal force going that way, again, it's a 90 degree from my displacement to my normal force. So the work being done there is 0 Newton meters. And then friction. Friction, I have to do a little bit of math there. I know that the sum of my forces in the x direction is equal to 0. And that means that my force of friction in value is going to equal the x component of that 12 Newton force. So that's going to be 12 newtons times the cosine of 25 degrees. Okay. So when I do the math on that one, I actually get about 10.7875, 875, and that's just newtons. Okay. I actually left it in my calculator, so to find the work done by friction, I left that 10.875 newtons. It has a little bit more beyond that. Times 5 meters times -1, which is the 180 degrees, right? Because I've got friction going that way and my displacement going that way, so it's 180 degrees. So that work is going to be -54.38 Newton meters. Okay, so that will take us through all of our work examples. Stay tuned for the next video to go through our energy problems.